Right, hopefully we don't have another malfunction here. Let's try and get through this. Okay, so you said this one was an issue. Is that right? Yeah, this first one. Okay, so I differentiated it, so hopefully that's fine. So going from this to this, I just differentiated. Yeah? Right, then sort of prompted by the fact that this is here, the A, I took out the 6 as a common factor. So that's that line. Now, this line. So I need, because of this bit here, I need what's in this bracket to be something squared, and it isn't. But if the -2 was a +1, then it would be something squared. But essentially, you can't just change the -2 to a +1, obviously. So what I did is I turned it into a little sum. So +1 minus 3 gives me my +1, but is still equal to -2. Does that make sense? So I want to keep the +1 with the trinomial, and I want to take the -3 outside the bracket because that's what's here. Now, when it's in the bracket, it's multiplied by 6. So I need to, where the position of the -3 inside that bracket means it is impacted by this 6 that's out here. Yeah, so if I'm going to take it out of the bracket, I need to multiply it by 6. So that's why it has magically become a -18. Yeah? And then this is now my something squared. So that is x + 1 squared. And there was kind of a lot of manipulation. So all I was doing over here was checking that I had actually done it correctly. So all I did was take that answer, expand it, and see if I got what I was originally starting with. So it was literally manipulation of a trinomial to turn it into a form. I didn't actually, the whole point was I didn't do anything. I didn't change anything. So 6 times x + 1 to be squared minus 18 is 6x squared plus 12x minus 12. Yeah? So it was just manipulation. So hopefully that's okay now. Let me know if it isn't. Oh yeah, this stupid question. Right, so what I was saying in my video with this question was that this was the aspirational questions when Project Maths came out first. This was either the sample paper or the very first, I think it was the sample paper, the Project Maths sample paper. And they had this idea that, you know, the way when we do maths, it's more about the process than the answer. So they had this idea that what if the answer didn't matter? So with this question, depending on what you do, basically there's a huge number of answers you could get. It's not about the answers, it's about the process, okay? So basically, you decide, right? So ignore all of this. So somebody stood down here on flat ground and used a clinometer. So a clinometer is like an upside down protractor with a weight hanging out of it, and you can use it to sight things and figure out the angle of elevation and the angle of depression. Again, it was going to be a big part of trigonometry and Project Maths, and it just hasn't really transpired. So that's what this person has done. They've sighted up the hill to the bottom of the tower pole thing. What is it? Pylon. And they figured out that the elevation of the hill is 10 degrees. So the same person from the same spot can use the same clinometer, and rather than looking at the bottom of the pylon, they look at the top of the pylon and they'll figure out what the angle is. Yeah? So this angle here can be figured out using a clinometer. And they've already said they have a clinometer, so grand. They also said then they had 100 meter, didn't they? Yeah, they had 100 meter measuring tape. So what I was saying was, it doesn't really matter what you measure. This is probably the more practical one to measure. Basically, walk to the bottom of the pylon and walk 100 meters back using your tape measure. Yeah? And over here on the side, if this angle is 10 and this is 90, this has to be 80. If this is on a straight line, this has to be 100. And from there, you have enough data, I think, to do, don't you? So we can figure this out. It would be... Sorry, I'm just making sure I actually have enough information. This... Oh, that would be 45. So you can do... Yeah, you have. You can do a sine rule. So you can do 100 over the sine of 45 equals x. So the height of the pylon over the sine of 35. And you can figure it out from there. Now, like, I completely pulled that 35, you know, out of my backside. You know, it could be anything. The 100 meters as well. I had a 100 meter measuring tape. I didn't need to walk the whole 100 meters. I could have walked 50 meters back. So there isn't a right answer to this. It was about, if you were presented with this situation, what would you do? Anyway, all of that said, these questions, it didn't work. It was too loose for students and they found them too hard to do. So we've gone back over the last, I don't know, long, 15 years. And the students are just given data. Yeah, so that's that one. And then what was the last one? Oh yeah, the Shoke. Again, this is early project math stuff. So that black line that I've highlighted there is a radius, and they've told you that it's perpendicular to BC and DE. So that is a line, how do you say it? That is a line through the center cutting a chord, and a line through the center that cuts a chord bisects the chord. So that's why I've got like these two green bits. I'm basically saying these are the same, and then these are also the same. So then what I did was I took those two triangles and I drew them out here. So I called you can see it there in the thing, I called that internal angle, this one here, actually it's in this one. I called this internal angle here beta, just to call it something. So in the green triangle, that angle is alpha plus beta. The bottom line from B to the center, sort of, as in, sorry, like this line. They're the same on both sides. Obviously, AB and AC are both radii, so they're the same. So what you have here are congruent triangles. They're identical. So everything else is the same. I then put them back together and drew the whole triangle. So like this whole thing here. And that's what's here. And then I just added, so I had alpha plus beta for the angle at the top, which is 2 alpha plus 2 beta and my 2 radii. I did the exact same thing for the triangle, the skinnier triangle, the yellow one. So again, the line from A to the circumference, the black line, bisects the chord. So that means DF and FE are the same. AD and AE are both radii, and as per my naming system, the angles at the top are alpha. And again, put it back and drew the big triangle, and that's just 2 beta at the top and then the 2 radii. Yeah. I did a little bit of maths over here. So it said that I think it was this piece of information, angle BAC, which is the big one, is twice angle DAE, yeah, which is the one in the, so this is the angle in the green triangle, yeah, and that's equal to twice the angle in the yellow triangle. Does that make sense? So that's what I'm trying to do here. So I said 2 alpha plus 2 beta is equal to twice 2 beta. Did a little bit of very simple algebra and ended up proving that alpha and beta were the same, which made the naming convention much easier. So instead of 2 alpha plus 2 beta, it became 2 alpha plus 2 alpha, which is 4 alpha. And instead of 2 beta, it became 2 alpha. So then I used this piece of information so that the areas were the same. So I got the area of triangle ABC. I'm using, the trig formula. So the area of triangle is a half AB sine C, where C has to be the angle in between A and B. So that's a half or times the sine of 4 alpha for the green triangle. And then I just simplified. And then same for the yellow triangle, half or times the sine of 2 alpha. According to the question, they're equal to each other, so I equated them. They both have a half or squared, so I divided across by that. And then I got, so I have sine 4 alpha equals sine 2 alpha. Now, this is from the Formula and Tables book. This here. I think there's a few ways to go from here to the end. It was definitely some kind of identities, but anyway, this is what I did. So the formula is sine 2a, and you can see by the highlight that 2a in the Formula and Tables book is 4 alpha in my question. Does that make sense? Do you know what I'm trying to say? So I'm dealing with 4 alpha. The Formula and Tables book has 2a. So that means a is 2 alpha. So basically I just did that. So I replaced the a here with 2 alpha. I replaced the a here with 2 alpha, and I replaced the a here with 2 alpha. So now the left-hand side, sine 4 alpha equals this, which I just put down here, and I equated it to the old right-hand side, which is sine 2 alpha. I had a sine 2 alpha on both sides, so I divided across by that. That gave me 2 cos 2 alpha equals 1, divided across by 2, so cos 2 alpha equals a half. Isolate the 2 alpha, so cos inverse, which was 60, and then alpha was 30. Okay, hopefully that makes a bit more sense.